Ever wondered why you can't just push two magnets together no matter how much you try? Or why you feel a shock when you touch a metal doorknob after shuffling your feet on a carpet? The answer lies in a fundamental principle that governs our universe: Coulomb's law. Coulomb's law, named after French physicist Charles-Augustin de Coulomb, is a law of physics that describes the interaction between electrically charged particles. It tells us how strong the force between two charges will be. To fully appreciate Coulomb's law, think of it as a recipe with three main ingredients: the size of the charges, the distance between them, and a special constant number known as the Coulomb's constant. Firstly, consider the size of the charges. Coulomb's law states that the force between two charges is directly proportional to the product of their magnitudes. In other words, if you increase the size of one or both charges, the force between them also increases. Secondly, ponder the distance between the charges. The force between these charges is inversely proportional to the square of the distance separating them. This means that as the distance increases, the force decreases, and it does so rapidly. If you double the distance, the force decreases to a quarter of its original value. Lastly, there's the Coulomb's constant, a number that helps us calculate the force. The constant is approximately equal to 9 times 10 to the power of 9 Newton meters squared per Coulomb squared. It may sound complicated, but it's simply a number that helps us make sense of the units we use to measure charge and force. Now, imagine combining these three ingredients in a mathematical equation. That's Coulomb's law. It tells us that the force between two charges is equal to the Coulomb's constant times the product of the charges divided by the square of the distance between them. In summary, Coulomb's law is a fundamental principle of physics that describes the force between two electric charges. It tells us that this force is directly proportional to the product of the charges, inversely proportional to the square of the distance between them, and multiplied by the Coulomb's constant. So next time when you see magnets repelling each other or feel a static shock, remember, it's all about the invisible forces at play, beautifully explained by Coulomb's law. It's a testament to the intricate and fascinating nature of our universe, governed by principles that we can understand, quantify, and use to make sense of the world around us. Understanding Coulomb's law is like holding a key to the universe's secrets.